Hello everyone. In this lesson, we are going to learn how to find volumes by Washer's method. In this example, I have a bounded region given by two functions. I start drawing the bounded region. So I have the y-axis and the x-axis. And the functions given is y equals 1 plus 2 square root of x. So let's draw that. Y equals 1. So when we start, x equal to 0, y equals to 1, because 0 times square root of 0 times 2 is 0. So when x is 0, y equals to 1. When x is 4, so here's 4, 1, 2, 3, 4, y equals to 5. So let's draw 1, 2, 3, 4, 5. So I have another point at 4, 5. This is 4, comma 5, and 1, 0, 1. And I know this is a parabola, opens to the right, starting at 1, and that would be my function y. So let's just extend it here and label y equals 1 plus 2 square root of x. Another function given is y equals x plus 1. That's a line. So we'll start at 1 because when x is 0, y equals to 1. So that is my second function. I'm going to use red. So here it is. And when x is 4, y is also 5. 4 plus 1 is 5. So here is my bounded region. And I take this bounded region and I'm going to spin it around the x-axis, rotating about the x-axis. So let's reflect down about the x-axis. When I reflect the two functions about the x-axis, I get something like this for the two functions. And it looks like a shape of a solid bowl, like this, solid bowl. And I carve out a cone, or a cone is removed. And it looks like that. So here's the situation that I have. I have a solid bowl and I remove the inside, which is a cone. The red cone here is removed. Let's look at the solid from a different angle. So first I started with a solid piece of wood in a shape of a bowl, and it looks like this. And then I carve a cone and I remove it from this piece or this block of wood. So my solid looks like this. If I take a cross section, I would get a washer or a shape of a donut. Let's draw it out here. So here's the cross section. So here's first start out with the solid, and then I remove a cone. I carve a cone and remove from the solid, and this is a solid. Right here I remove a cone, and then I take a cross section. Here's the cross section, and the cross section looks like this. It has a big circle, and the little circle is removed. It looks like a donut, and we punch a hole through it. This donut has a thickness, and the thickness here is delta x, and the radius from the outer to the center of the circle, we call it big R. And the radius that we remove from the big circle, it has the little radius, little r. So let's find the area of this washer or this donut. So we can say the area is going to be area of big circle, so area of the big circle is pi big R square minus the area of the smaller circle, so we're going to say pi little r square. And if we factor out the the pi, because that's the constant, we can say pi, bring it outside, and parentheses, big R square, big radius square, minus the little radius square. And that's the area of this washer. To find the volume of the washer, we are going to say V of x equals the area, which is pi, times big radius square minus little radius square times the thickness delta x, and that's the volume. So let's find what is the big R. What is the big radius? The big radius is going to be the outer function. Let's take a look. Here is my big radius from the outer function, which is 1 plus 2 square root of x, minus the center of the circle, which is y equals to 0. That's the x-axis, y equals to 0. So let's write that down. The big radius big R, or over here we can see the same thing from the outer function minus the center of the circle. So we will write outer function minus the center, that is R of x, the radius, big radius, is going to be 1 plus 2 times the square root of x minus 0. That's the center, y equal to 0. To find the little r, or r of x, little radius, we are going to take the inner function. Here's the inner function. The inner function is a line, y equals to x plus 1. And let's label it here, y equals x plus 1. So let's write that down. We have inner function minus the center. And the inner function is going to be x plus 1 minus the center function, which is y equals 0. So we say minus 0. Now let's put everything together. So we have our volume, V of x, equals the integral going from 0 to 4. Let's put pi outside, times big R square, minus little r square, times dx. Let's look at the integral and the limit of integration one more time. The reason why we put 0 to 4, integrating from 0 to 4, because we're stacking all the washers, starting from 0 all the way to 4, from the beginning at 0, and it ends at 4. So let's label that. This is 0, and it ends at 4, and that's why our limit of integration starting at 0, and it ends at 4. Now, we are going to substitute our R, big R, and little r. So volume is going to be integral from 0 to 4, and the pi is outside. And we have big R, 1 plus 2 square root of x square, minus the little r, which is x plus 1 square. And all this is the area times delta x, or dx. When we put it in the integral, it becomes dx. Now, we have volume equals, let's just multiply everything out, from 0 to 4, integral from 0 to 4, 1 plus 4 square root of x plus 4x minus x squared plus 2x plus 1, and times dx. Using distribution, I'm going to get pi times the integral from 0 to 4, 1 plus 4 square root of x plus 4x minus x squared minus 2x minus 1 times dx. And I see 1 minus 1 becomes 0. And I have here 4x to the 1/2. Square root of x is x to the 1/2. And 4x minus 2x is just 2x minus x squared times dx. And let's put that integrate from 0 to 4. Leave the pi outside, and that is our simplified function. Now we integrate. When we integrate, we're going to get pi times 4 times 2 over 3 x to the 3 over 2 plus 2 times 1/2 x squared minus 1/3 x to the 3rd. And all of this is evaluated from 0 to 4. Now let's take a look. When I substitute 4 in for x, I get 4 and take the square root would be 2. Cube, 2 cube is 8. 8 times 2 is 16. 16 times 4 is 64. So let's write that down. I have 64 over 3. Next, when I substitute 4 in for x squared, 2 cancel with a 2 here. So I just get 4 squared is 16. So let's write that down. Plus 16. And next, when I substitute 4 in for x, 4 to the 3rd power is 64. So I am going to get 64, but it's negative 64 or minus 64 over 3. 64 over 3. And next, when I substitute 0 in for x, all of these 3 terms is going to be 0. So because 0 raised to any power is going to be 0. So let me write that down. Here is minus 0 for the total. It's going to be 64 over 3 minus 64 over 3. And don't forget the pi outside. Our final answer, since everything cancels except 16, our final answer is going to be 16 pi cubic units. And 16 pi cubic units. And that is our final answer. Good luck on your homework, and I will see you in the next video.